This set of data I'm going to use to illustrate chi-squared analysis. The set of data is taken from the Altiplano of Bolivia. A research team from DCU went out to Bolivia and they carried out a sensitive and accurate analysis of people's blood to detect whether they were infected with liver flukes or not. And in the villages that they investigated, you can see that out of 76 people who were young, 50 of those were infected, whereas for the old people, only 5 of 18 were infected. So it looks like there's a difference in the rate of infection for young people as opposed to old people. What we want to do with chi-squared analysis is to find out, can we determine whether this is statistically significant or not. And the way we do this is through chi-squared analysis. The first step is to work out the expected values. So here we have the observed data. From the observed data we want to work out what would be the expected values if everything occurred purely by chance. So to work out this expected value here of 76, we take the row total, that's 55, multiply it by the column total, which is 76, and divide by the grand total, which is 94. And that will give us this value here of 76 for the expected. And we do this for each of the cells. So if I click in this cell here, you can see that it's the row total times the column total divided by the grand total. Finally, we need to compare the expected values with the observed values. And we can do this on the back of an envelope if we wish, simply by using the formula. It's the observed minus the expected, all that squared, divided by the expected, and all that totted up for each of these 4 cells here. But SPS Excel has a tool which will allow us to do this, which is called chi-test. So if I click in the cell, you'll see there is chi-test. So you could simply type this in, is equal to chi-test, open brackets, the range that contains your observed data, comma, the range that contains your expected data, close bracket. Or you can get it from insert, function, and then go to statistical, and chi-test is within that. Just one word before I finish about this. This is the simplest form of chi-squared analysis. It's called a 2x2 contingency table. So you can see you've got 2 columns and you have 2 rows. You can have any number of rows and any number of columns, but we're just giving this as the simplest example. And finally, you can see here that the expected values are all reasonably large. If the expected values fall below 5, then you'll need to apply a correction to it called Yates correction. But that's a little more advanced. I'm not going to go into that. You can look it up in a statistical textbook if you need to do it.